Hello everyone, welcome to the Biocatalysis channel.
Today we're going to be talking about vitamin C and how biocatalysis can apply to it.
Vitamin C is really common. It's in many kinds of fruit and many people also take vitamin C supplements.
That's true. Vitamin C is an essential nutrient for humans. It is a natural antioxidant and can help us absorb iron, heal wounds and form important proteins such as collagen.
It seems really important to our health.
It is. However, we cannot synthesize vitamin C by ourselves. We need to get vitamin C from other sources such as food and drink. This is the reason why it's a commonly used nutritional supplement, and over 80,000 tons of vitamin C is produced every year.
Okay, so how can biocatalysis help in this case?
Well, the biocatalyst helps the synthesis of vitamin C a lot, and the process is much more eco-friendly than the traditional method. But first, we should take a look at the method currently used to make vitamin C, the Reichstein process. It was devised by Nobel Prize winner Thaddeus Reichstein and his colleagues in 1933.
Sure. So the reaction starts with D-glucose. What should we do first?
First, we need to add hydrogen to the D-glucose. To do this, we have a mixture of glucose and hydrogen under 150 atmospheres of pressure and high temperature with a nickel catalyst.
Then we get D-sorbate. What's next?
Next, we add Acetobacter suboxidans, a kind of bacteria, into the reactor. This bacteria will produce enzymes and stereoselectively convert D-sorbate into L-sorbose. Remember, the optical properties are important, as if you get the D-ascorbic acid, it will be of no use to our body.
So the biocatalyst, this bacteria, it helps us solve this problem. And?
After that, we want to oxidize the hydroxyl group into a carboxylic acid.
Then we just add some oxidants into it.
No, we can't do that because the other hydroxyl groups will also get oxidized.
I know. Then we need to add a protecting group.
That's right. So we add acetone as a protecting group.
Then the potassium permanganate is added to oxidize the top hydroxyl group.
That's right, and we're almost done. The compound is called 2-keto-L-gluconic acid. Under acidic conditions, it will undergo ring closing by dehydration, and then it becomes vitamin C.
Wow, that is a long process.
Yes, and the process is not friendly to the environment, even though its percentage yield is quite high.
That's true. We can see that hydrogen is used in the first step. It's an explosive gas, so the risk for accidents increases.
Also, high temperature and pressure is used. This means a lot of energy is required.
And third, a protecting group is used. It is usually thrown away after and will produce lots of waste.
Acetone, an organic solvent, and potassium permanganate, which contain heavy metal ions, are used. They are toxic to the environment, and energy and water are needed to treat them before disposal.
Lastly, the atom economy for the Reichstein process is low. It's only 40%. This means that when we use 100 tons of reactants, we only get 40 tons of vitamin C, if the percentage yield is 100%. The waste is huge.
The Reichstein process is used in many factories, but from a green chemistry point of view, it is far from ideal.
Let's see how biocatalysis can help us. Okay, so this is called the one-step fermentation process. Before we start, let's introduce our helpers, the biocatalysts.
Right, the first one is called Erwinia herbicola. It is a bacteria that can convert D-glucose into 2,5-diketo-D-gluconic acid. And the second one is called Corynebacterium. Also a bacteria, it can convert 2,5-diketo-D-gluconic acid into 2-keto-L-gluconic acid.
So, by combining the two bacteria, we can convert D-glucose into 2-keto-L-gluconic acid. The 2-keto-L-gluconic acid will transform to vitamin C in acidic conditions.
But there's a problem. The two bacteria like living in different conditions. They cannot work in the same reaction tank, so scientists transfer the genetic information to express the enzyme 2,5-DKG reductase from Corynebacterium into the genome of the Erwinia. Then, the artificial Erwinia hybrid strain can directly transfer D-glucose into the transfer D-glucose into vitamin C in only one step.
Cool, but why is the one-step fermentation process considered green?
It is considered green because it satisfies 7 out of the 12 green chemistry principles. Number 1. Prevent waste. Enzymes are highly selective, so they eliminate any byproducts. Also, reagents such as hydrogen and potassium permanganate aren't used. This minimizes waste. Number 2. Maximize atom economy. The atom economy for the Reichstein process is only around 40%. For the one-step fermentation process, the atom economy is 100%. Number 3. Design less hazardous chemical syntheses. Hazardous reactants such as potassium permanganate and acetone are not used in the one-step fermentation process. Number 4. Increase energy efficiency. The reaction temperature is near to room temperature, which means less energy is used to heat up the reaction. Number 5. Avoid chemical derivatives. We do not need any protecting groups because the biocatalyst has a high selectivity. Number 6. Catalyzed reactions are superior. In this case, the Erwinia hybrid strain is our biocatalyst and can transform D-glucose into vitamin C directly. Number 7. Minimize the potential for accidents. Toxic organic compounds and heavy metal ions are not used in this process. The potential for accidents polluting our environment is minimized. Explosive hydrogen gas is also not needed.